welcome to the video. This is a walkthrough on Chocolate Factory on TryHackMe. Pretty cool little easy beginner type room. It's a challenging room as it doesn't lead you in every step of the way to do things, but it's an easier room because there's not much like to really have to jump through major hoops to exploit and such like that. So we'll look through the room, we'll walk through it, and get you to root on the box. So let's get started. So here's the room on TryHackMe. Like I said, it's more of a beginner-friendly room. Cool little ticket there, and then it has the challenges. So it's kind of a mix between a beginner and a more harder room where you just have to kind of figure it out. So this one is also a little different in that it just doesn't ask you for the user and a root flag. It's asking you for different things. So again, kind of leading you in that direction, but not too much. All right, we got the IP address. So we'll start our basics of working through the room like we normally do. So let's get into TryHackMe directory, and then we'll make a directory for this one. We'll call it, let's just call it factory. Okay. So again, I always like putting the IP address into a text file called targets, and that way I know I'm always working on the same data, and I'm not accidentally going past my scope or anything like that. We're going to split the window here and get the Nmap scans going. So we're going to do default. We'll do some HTTP scans. We'll try FTP because that usually ends up happening. We'll do vol and version. Output all formats and call that detailed. Okay. But definitely some interesting ports here. FTP, SSH, and HTTP seem, these are normal ports that you would kind of maybe see on some kind of web service or something kind of exposed. But then we have some additional ports from 100, 106, 109, 110, 111, 113, 119, and 125. So one of the ways you can kind of like just probe these is to see what's going on. So let's do targets.txt, and then we'll try 100. Small hint from Mr. Wonka, look somewhere else, it's not here, hope you won't drown Augustus. Okay, so it's like a chocolate. So what we did is we used netcat to just connect to that raw socket on that port, or using that raw connection on port 100 to connect there and seeing if a banner comes up. So sometimes when you're querying some of these ports, if something doesn't come up, you can push enter, you can try help, you can try some other commands to kind of see if a prompt will pop up. And this is a way of like a manual probing of the port to see if there's some other service running behind there. So in this case here, what it looks like is that there's some kind of daemon sitting there that once it gets a connection in, it just spits out this um, text in ASCII art. So we can try the other ports too and see if something else comes up. So we'll try 106. So in this case here, you'll see that the prompt is still ticking. There's nothing there. So I'll try and help. I'll try. Yeah, so nothing's coming back. So I just push Control C on that one. So we'll try a different one. Okay, so 109 does the same thing. Try 110. Nothing there either. Again, we'll push enter. We'll try help. Try question mark, slash, get slash. Yep, nothing there. 111. There's definitely seeming like there's some ports that have that service running, but some of them do not. 111. Let's try 113. Nothing there. And 119 and 125. 19 and 125. And another prompt. Okay, so not much from that. Let's look at the website, see if we got anything from that. Okay, so it's looking at the squirrel room. We'll do our standard looking at the source. Again, this is mostly in CTF's type thing where you look at the source of the page. I found it on a couple web apps where, you know, a developer has left a comment in the page, but majority of the time they're not going to leave a comment in the page. All right, so from the source though, I did gather some good information here, and let me make this bigger so you can see it. We can tell that we are definitely using PHP because the action is going to be set to validate PHP. So we know that the backend is using PHP in this case. So we did get some information from looking at the source. So we have that. We'll go ahead and start running GoBuster on this, and then we can maybe look at the other ports there that we had. So let's do, and this is going to be factory, and we need to change the IP address there. Okay, that should be right. Yep. Okay. Okay. So we got those two running with scans. Let's cat back out our initial results and see what else we can do. So we did have FTP. We can try anonymous on that. That's usually another quick kind of check to see manually. So let's try that. So again, just using that bash and concatenation there, inline running. And No name or service. Make sure we are still, yep. Let's, okay. So this time it didn't allow me to specify the account beforehand. And we'll just put anonymous. All right, so anonymous login is allowed on FTP. So in a normal pen test finding, this would be in a normal pen test report. This would be a finding, of course, that one, you have clear text protocol, and then two, that you have anonymous login enabled. So we want to do the dir A. We want to make sure the reason that we do dir A versus ls is any files that would have periods at the beginning are hidden by ls, and so by doing a dir A, we see everything in this directory and all the files in there. So we have one file. It's called gumroom. So we'll get that. So immediate thing that kind of jumps out to me is that this file is pretty big for a JPEG. Another thing we want to try sometimes is see if we can do a cd slash and then do a dir A. Again, we want to make sure they actually char rooted the FTP directory correctly, or wherever they set that up. Yep, so it looks like they did. So what I did there is I did a cd slash or a cd dot dot slash dot dot slash dot dot slash directory transversal. So I'm trying to see if they didn't set up the char rooting correctly, you could escape out of the directory that the FTP service is running, and then basically kind of work into the file system that way. But in this case, they did, so we're not getting anything there. All right, so we're going to quit that. We'll go ahead and make our loot directory. Again, we want to keep these things that we pull off the systems there, so we'll move that gum room into that loot directory. Let's clear this, and then let's move into that loot directory. While we're waiting, before we get onto that, let's see how our scans are going. Okay, so we got a couple errors back. Timeout exceeded, nothing major there. It looks like Nmap is still scanning, brute forcing some FTP things. Looks like it's got about 3 more minutes left, so that's fine. Okay, so we have gunroom. Let's see if this is an actual image first. So we'll go into CTS, we'll go into TryHackMe, we'll go into factory, and open the folder. Okay, definitely looks like there's something there. So it's a standard image, it's nothing, maybe like, again, in some of these CTF environments, it might be a picture of a password or something like that, or things like that. So it's good to kind of go look at these things and see what's going on with that. All right. So again, the file, a JPEG file this big, kind of alludes that there's something inside of there. So we can do a couple of things first. We could do strings to see what we pull out of this. Oops, I put string instead of strings. There we go. So again, strings just looks through that file. Anything over 4 characters long, it prints out in the hopes that basically this is readable text. Sometimes it's not, and as we can see here, this is not a lot of readable text. So we do see EXIF. There's some character sets there, and then a bunch of gibberish. So that didn't give us much there. Let's clear that. Let's do our EXIF tool. And okay, so sometimes things get put into the comments or that type of situation. So we don't see anything sticking out here. So then the next thing that we should look for is any steganography or anything like that. So we can do stag and that's usually on the system. And you usually extract and then the file name, and we're going to be Gumroom. We don't have a passphrase, so we can try blank and see if we are successful. Okay, so we did get something. So sometimes you, for stag you might need a password to get that out. And in that case, we should have got that data somewhere else, but we didn't need that. So we did get base 64 or B64 text file. If we cat that, I'm going to guess it's base 64. Yep. All right, so a good indicator of this is you'll see a majority of the time equals equals at the end. That's a good indicator that it's base 64. So we're going to, we'll cat that file. We'll go ahead and pipe it through base 64-D. So we're taking all the contents of this file, and in Linux, we're piping it, which means we'll take whatever the results of that is, and then use that as standard in into base 64. And base 64 has a decoding options, and that's why we're putting -D there. Oh, right. So that looks like a shadow file. Yes. Yeah. So there's password PASSWD, which most users can read, and then the shadow file, which only root or admin users can read. And the reason that I know this is a shadow file is because there is a hashed password here. There's none on the other ones. So funny enough, this is probably from some kind of Kali instance or parrot or something like that, because there's accounts in here that definitely talk to that, like Kingfisher, Beef XSS. There's an Open VPN. This one says Debian XM though. That's interesting. ARPWatch, Shell in a Box. There's a MySQL account that was on this system, wherever this was pulled from, not my system. So pretty interesting. Again, insights into other accounts that would have been on that system. None of these are, like really jumping out. It's just more of a type thing. So we'll pipe that, output that into Shadow. So again, cat it, output everything on this text file. I took that, I pushed it through into base 64, decoded it, and then I saved those results into a Shadow file. So now, if I cat Shadow, that's just the results basically. So, all right. So with this, now we need to kind of crack this hash. So we can copy this. And what we'll do is go. This might not work because of the slashes. Yeah, let's just do nano. Nano, crack, password. Okay. So we got the way it needs to be formatted is Charlie, and then the hash password there. Okay, so we'll save that, and then we're going to run John. So we have John, and we're going to do crack password. We'll tell it format. So that looked like a SHA 512 crypt, and the way that you know that is, let me cat this out again real quick. This beginning section right here between the dollar signs tells Linux what hashing algorithm that it's using, because it has to do this. You know, it has to be able to take the user input and then know that to see if whatever you put in makes the same sense. So yeah, there you go. So we see here, is this going to tell us? It's not going to tell us. There you go. So a $1 would have been MD5, $2A is blowfish, 2Y is blowfish, 5 is SHA-256, and then 6 is SHA-512. And you get to know that after a while of seeing this over and over and over and over. So that's kind of how I knew. It was just that off the bat. But I wanted to show you how to figure that out. So SHA-512, crypt, and then we're going to do word list equals / user share word list rock u. Again, rock u is the kind of standard CTF-y type password list to use for this. On a real engagement, you should build a password list in combination with using ones that you have to kind of crack passwords. All right, so this is going to do its thing. Let's go back and look to see if we got any more information. Looks like GoBuster is running into errors there. Let's see what else. So we really didn't get too much more off of Nmap, which is interesting. So with it being SHA-512, it might actually take a while to crack. So let's split this up, and our current GoBuster session is just looking for directories. We haven't found anything yet, which is usually kind of a good indication that you might not find anything. Most of the CTF boxes, they don't they don't hide too much. It's within the first couple of things. So let's also try some extensions. Things like we know PHP from before. We could try like an HTML. We could also try some backups, so like back or zip, maybe an SH, see if there's something like a shell script that was lifted on something somewhere. JSON, .git is another one. So let's try that and see if this comes up with anything. All right, so we did get an index, which we kind of know that this is probably the index. Oops. Okay, yep. And then we could also try PHP to validate that. All right, so it's not index PHP. So that's fine too. And index HTML can submit to a PHP file to kind of do it that way. That's not out of the norm. All right, so let's see. Got a home.php, okay. Let's look at home.php and see if something is out of that. Oops. All right. Well, that's interesting. So it might be hard to see on the screen here, but when you submit something, it basically looks like that it's running that and then displaying it there. Let's see if we can view the source of the page and see if we get anything. So it's a post command. It looks like it's taking an ID of com. Let's see if we could curl this. So I think I'm gonna want, let's see here, curl with post. Yep, so post, all right, and then I want to send some data, which that should be it right there. Okay. So if we do this right, let's try that. Okay. All right, so looking back at our page, what I'm looking at here is that we need to have an ID or a com there for that post. So we're going to do com, and then that's going to be the command that we want. So like this would be, let's try who am I? Okay. And then we also need to change where that's getting submitted to. So that's going to be this location here. Okay. So if I did that right, we should get, nope, I did not get it. Name command. Let's try, maybe it's command. There we go. So there it is right there. Dep data. So now we have a way to kind of just execute stuff. We could clean this up and just look for that results. Write like a shell script or something like that. But this will work fine too. So we have a way to execute information. We are www data, so that's not going to get us too much there. What else can we do? So let's see if we can list out any files. Okay, so we do have a index PHP back, so that's interesting. There's a key rev and a validate. So we could see what the validate's looking at, and not have to worry about a login. We're gonna do %20 because I'm doing a space here, and then validate. So the reason I'm doing %20 is when you submit stuff via post or GET, you have to URL encode it, and a %20 in URL encoding is a space, and so I'm writing out cat space validate.php. I didn't mess it up, and I didn't. Haha, cool. So here's what we're seeing, right? Is this is the file, but the bigger part is that we got that right there, which we now know Charlie's username and password from catting out that validate, because that's what was needed to log in. That's what we were seeing here, and we saw before that this page source is sending that data right here to validate.php. All right, so that's cool. I guess we'll see if that ends up being the same thing that we'll see whenever this cracks, hopefully within time. All right, let's exit this one. Okay. All right, so we can try logging in with that and seeing if we get anything. Charlie, and then I'm gonna save that credential somewhere. Let's go cd loot. I'll just echo it into a text file. I need to put the single ticks around there. Copy it, paste it, and then we'll put that into, let's just call this validate php underscore pass dot text. Okay. So then we'll also copy this again and make sure we have that in the clipboard, and we'll go here and see what we get. Okay, so it sent us to the home page anyway. So so we just got back to the same place we were at, which is all right. That's fine. That's not a big deal. We didn't get any further. Uh, that's funny though. All right. Okay. All right. So we're back at the home PHP. If that was like an admin page or something like that, again, that would be a big finding or write up for me. That would be that the admin page, the home.php, is not actually secure, that anyone can access it. The I've had developers though push back before and sometimes be like, well, they would have known about it if they didn't, if they never, were able to get access to it. And nah, that's not a valid thing. So, okay, all right. So let's look back at what we were running before. Go back to our little sudo command shell here via curl. And I'm doing it this way because it's just a little bit easier to kind of see what's going on. So we do have an index php.back that we could look at. We also have this key rev key. So let's Oops. Let's do. We'll look at the index php.back, see if that gives us anything else, and if not, then we'll look at that key key, uh, the image PNG and the home JPEG. We could pull those if we go down that route, or if we need to. Cat index. All right, what happened? Oh, I messed up my. There we go. Okay, so this is just a. Yeah, so this is what we're running now. So this used to be index php.back, which is very insecure. Like you shouldn't have the ability for your PHP scripts to run code on your server. That's just a bad thing to do. All right, so we'll ls again. We're gonna now look at cat key, and then what we're gonna do is probably just go ahead and shoot a shell. So we'll end up doing some kind of thing to give us a shell here, because we need something better than this. Key underscore rev and then key. Interesting. So it says it's a binary file. We could try to strings it and see if there's anything in there, but at this point I think we're going to end up having to go to. So if you never noted before, is when you compile executables, a lot of data gets kind of put in there. It's interesting. And so these are strings inside the executable. In this case, it looks like it's in some kind of ELF binary. Looks like it might have been compiled with glibc. Probably 2.7 since that's the highest one up there. We looks like we got it some kind of name, and then it says okay. There's a key there. This looks like more base 64 data. We can try that here in a second. So it was compiled on a Ubuntu 18.04. Yeah, so it looks like it's calling some libc main functions, puts, which if it's calling puts, I know puts has a buffer overflow, but again, if this is not running if this is not running, then it's not really going to help us, and we would need some way to contact that and do all that stuff. So let's see if that data that we saw in here is base 64. So we'll do the same thing similar to what we did before. We're just echoing this now, that string, and then we'll do base 64 and -d. It doesn't look like it. Maybe it's with the dash. That doesn't seem right. Yeah, that's not right. Okay, so we can see if that just is acceptable. Yep, okay, so that was correct. All right. So at this point, I feel like we should just go ahead and get a shell going. Um, let's see what if we have like Python or We know we have PHP, so we can maybe upload a PHP shell and then do it that way. So we could do which %20 Python. We do get a user bin Python, so Python is there. We could do which PHP. We know PHP is there, but okay. So we have either shell options there. Um, let's see here. PHP would probably be the easiest. We can execute that to download our PHP. That should save it onto the server in the directory that we're in, and then we could be able to run it. So let's do that. Let's get, do we have which, let's make sure we have wget, because that's the way we're going to do it. Which %20 wget? Yes, okay, good. All right. So we'll wget, we're going to do a %20, and it's going to be http colon, which I'm going to have to encode this, I know. So let's pull up CyberChef. Um, did you see CyberChef there? Mining Bitcoin. All right, http colon slash slash. We're going to put in our IP address. Yes, I know, thank you. Colon 8000, and then we're going to do like, we'll just call it revshell.php. All right, so then what we need to do over here is find your URL encoding right here. And we just drag that recipe over here, and that should bake. Yes, encode all special characters. Thank you. All right, so what you see here is that it encoded the slashes and the colon and the dots, because those all mean different things whenever we submit that via web form. So okay, so that should be good for that. Now we need to actually put that on our, we need to host that. So we're gonna dot dot. We'll do that. We'll make directory payload. Okay. We are going to need to do let me split this again. I know what I'm calling it. All right, so again, in Kali you have a program called web shells. All it does is cd into a directory called user share web shells. In this case, we're going to go into PHP, and if you ls, then we see a PHP reverse shell. So we want that one. So we're going to cp that user share web shells PHP rev shell to here, and oops, and we're gonna call that rev. I think we called it rev underscore shell. Yes, rev underscore shell underscore shell.php. Okay, so now if we look, we should have rev shell.php. We need to move that into our payload directory. Okay, all right, so now I can exit this terminal. Let's clear this up again, and let's look at it real quick before we just execute it because we want to make sure we might have one or two chances to do this, so we want to make sure all the code's good to go. Oh, cd payload, then I'm on a code. It's rev shell and then user data dir equals /temp, and then Visual Studio Code will start up. It'll yell at me for doing it as root, but that's fine. All right, so again, this is standard Pentest Monkey PHP reverse shell. What we want to change is these things here. So this. Oops. Okay, that's the IP address that we want. And we're going to go ahead and specify, let's do all fives. So 4 fives, there we go. Okay, let's, I'm sure we have bash. We'll see here. Let's try this. Where's that home PHP? Which bash? Yep, so bin bash is there. Yep, so bin bash, that's fine. Okay, so that's gonna say, we're gonna save this now. So that should be good to go. Okay, all right. All right, so now we need to run a web service on our server. This is going to automatically be on 8,000 if I remember correctly. If not, we can specify 8,000. And then what we'll do is we'll issue this command. It'll grab the reverse shell from us, put it on the server in that directory. We'll verify that and then run it. Yep, so there that is. There's the get command. We see that it grabbed it. Excellent. We can now also ls and just verify this up here. Move this down a little bit. It did not write it. Okay, let's try with the -o. %20 -o %20 rev dot shell %2e php. Did that not work? So it didn't save it the first time is what it looked like. I might have all encoded this way too much. So we'll try it on the PHP form up, the actual one that we have here. So again, wget http / IP address $8,000 All right, so that didn't work. So we're going to need to pull a Python shell because we know Python's on there. So oh, that's way too long. There's like a, I know there's like a cheat sheet. We need like a one-liner. We don't need like a whole program. Yeah, there's the pen test monkey. Really? Really? Wow. So payload all the things is another good one. There it is. We're gonna do this one. So quite long. Let's open up code and then change it real quick, and I can explain it while we're looking at it in code. New file. Thank you. All right. So can you highlight this? Thank you. So it's going to do a Python command. It's going to import socket and subprocess and OS. It's then going to do a variable called s, and it's going to initiate the socket class and call the socket function, which then calls the socket class .af underscore inet and socket .sockstream. And then sconnect, it's going to connect to our IP address, which we need to change. And this port number. Then it's going to use the OS, and it's going to run the dupe2 function with the socket and file no, which is a file handler, 0, and then OS dupe2 file no 1. So your standard in and like standard out and error, and then import pty spawn bin bash. So basically, it's just going to take the shell, push it through the socket to this IP address, and then listen for that there. All right. Let's nc lvmp all fives. We'll close this, and that's good there. Now we can run that in here. And we should get a shell. There we go. So now we have a shell on the server. All right. Let's see here. We could upload our linp script and get that going. So again, that's going to be, for me, I put it in my opt directory so I remember where it's at. So that's going to be cd opt. There it is. Anytime you're using any of these projects, you want to do a git pull, kind of have the most up to date. We can see that WinPs and LinPs were updated to 2 changes, 29 changes on the WinPs program. So again, it's good to always keep it up to date. We want LinPs, and that's going to be the .sh file, and we'll need to pull that in there. So Python, there's that. Oh, I need to specify HTTP. 10.2.12.219. That's it. 10.2.12.219. Yep. And then port 8000. And then it's going to be linpeas.sh. Okay, so let's see it pull it down from here. Great, we can kill that now. We can exit this, and we can clear and then run linpeas. Of course, clear is not set. That's fine. Okay, we need to set the execute bit on this. All right, so linpeas is now running. Let's see if we got anything anywhere else. So we're still striking out with GoBuster. We did finally correct Charlie's password. It's the same one that we had, so nothing different there. So no additional findings there. Ooh, man. What in the world is all that? All right. Oh, we need to see. So this is saying sudo. Might be able to run sudo. That might just be an easy one. I'd love to see a box where they hide a flag in the environment variables. That would be good. I know I've seen it on major CTFs, but I don't think I've seen it on any of the TryHackMe boxes where they hid a flag in the environment variable yet. So, oh, where are you going, Linpeace? What are you doing to me? What is going on? So, like Linpeace is just spamming so much stuff to the terminal. There we go. Can I go all the way back up? Man, so it is like having a process on every possible port or something, or that's a lot of procs going in system devices. That's kind of what killed everything there. Uh, I hate to run a script twice, but let's tee it. And then that's going to be output dot text. All right, before we lose everything there. Yeah, that's already filled up the buffer. So this person, they did this probably on purpose to kind of mess up you running linpeas. We have all these netcat listening services going on. There's nothing in the cron there. Yeah, they just have everything listening to kind of fill up all that space. All right, so we see Charlie can run VI with no password. That's probably the privilege escalation. So we'd have to get to Charlie, which we can switch to Charlie because we have Charlie's password. Cat validate. Oh, fine. CN 7824. Okay. Is that's not Charlie's password? Can we look at Charlie's home directory? Yep. So there's Charlie. Okay, so we got teleport pub, and user.txt. Again, I'm dub, so I can't do much. So we can read, yeah, we can read teleport and teleport.pub. What's teleport? I'm gonna guess it's a key. Yep, I was right. All right, so copy. Okay, so we just save that key. Okay, and then teleport. So again, we're SSHing as Charlie. We're executing this bash statement first, which is just going to replace IP address. And then we're using the key teleport, which we copied from the server, guessing that this is probably Charlie's key. Charlie's key apparently needs a password. Is it the CN78? Two four. I think I mistyped that. CN7824. No. Okay. Let's see. Make sure I have the right permissions on the file. Maybe that's the thing. Oops. Well, I should put the key in front. Sometimes I teleport. Oh, what are you doing? Okay. Charlie. Okay. Okay, let's see if that works. There we go. Haha. All right, so we now have a working SSH session as Charlie. So one of the things that we did notice from before is that he could execute vi via sudo, and we can also just sudo -l and see what Charlie can do. So Charlie can do all commands not as root, um, but he doesn't need a password to run vi. So um, what happens here is that it's going to run vi as root, and we're going to be able to do privilege escalation. And the way that you can do that is gtfo bins, and since we know it's vi, we'll look it up here and see how to do it. So we're going to go to vi, and we see right here, here's vi, and here's all the different ways that you can basically use vi to get access. So what you're going to do basically is break out of vi, and we're going to use that to kind of to get out of there. So we'll try this one right here. And see if we can get root. So we'll do sudo, do that. We'll do bin bash because I like seeing the shell. And there it is, root. So now as root, we have access to the whole system, so we can look at the flags that we need to do. So ls should be in the root or home directory. Do we have root? Yep, root. There we go. So there's a root pi. Interesting. So maybe we're not done. All right, so we're gonna need something else maybe. What are we looking at here? Encrypted mess. So cryptography fernet get. So if we run this, Python root.py, enter the key. Is that from before? This key? No, apparently not. I did not like that key. Do we need to not have just that? Let's try that. It is not liking that key. Hmm. Well, this is an interesting one. Uh, all right. Well, let's maybe look at maybe we're missing something from the user flag or something like that. and that would be the key. There's that. User. Okay, so that's just a flag. Cool. Copy. Charlie's password. 7424. Okay, we're in, and let's take the hint. Use Python instead of Python 3. Yeah, I think I was doing that. Yeah, it is not liking that one, which is interesting. Dun 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 dun. Let's see if... Alright, so there's no bash history. All we have is that root.py. What is Fairnet? I'm going to copy this. I'll put it right here. That way we can read it better. Okay, thank you. Python again. Alright, so let's see what Fairnet is, if we could figure out the key. Copy. Fairnet. Python. So it's symmetric encryption, okay. So there's the encrypted mess. F decrypt, okay. So it's calling it there. Key equals generate key. Okay, so it's some kind of symmetric encryption. So we need a key. The only key that we got was the one that we submitted from before. But that's not working. Let's see if on this system we get a better view of the key. So where was that at? That key was in the cd var www HTML directory. Yep, and then so we strings key.rev key. Okay, so that's copied there. And let's Python root.py, paste it. Can we hex dump it maybe? Yeah. Oh, hex dump, ASCII. Well, that might be it then. It's supposed to be decoding. Oh, XXD, I guess would work, or dash C, either one. Okay. Dash big C. So I'm doing a little different dumping here to see if maybe I'm missing a character or something. Because it does not like the information I'm giving it into the program. We found the key, there's the bytes. Yeah, so I mean that looks the same. Can I run it? Do I need to make it executable? Yep. I'm root. I totally have permission. Okay, so that's similar to what we were looking at before. Let's see here. So in, what was it? Um, it wasn't shadow. No, maybe it was just when we dumped it that we saw bad username. Yeah, I am perplexed on this one. I'm not sure what to do. Because we have a key. That's the only key that we have. And we're putting the key in. Just like it was saved in there. Unexpected end of string while parsing. Okay, so then it's taking what we put in and it's not defined. Do we need to use Python 3? Yeah, there's no pyfiglet. Alright, I'm gonna have to end the video there. I'll leave a comment in the video on YouTube if I figure out what it is, but this is definitely something's not correct here. I mean, unless we're supposed to put the encrypted mess. Hold on, let me try that. That seems dumb. Why would you do that? Is this what you're talking about? Yeah, it seems like the program's messed up or something. Because it keeps saying blank name is not defined, so it's like it's trying to call that function, which is not right. Um, just seeing if I missed anything else in here that might help us. Alright, let's try that name. And then congrats, we found the key. Cool. Copy. Paste. Yeah, no clue. This is, yep. Alright, sorry to end the stream on not giving root, but there's something not right with this, and I'll have to figure it out and see if maybe I can do it some other way that might be more complex. So I hope you enjoyed the video so far. And then once I figure out what command needs to be ran, I'll put it into the video on YouTube. All right, thanks. Have a good night. Bye. All right, Lord Saibot here again. So we left off where we were not able to figure out what was going on and why the the key was not working. So when we did strings on the key, what we noticed is here's the key, and what I assumed was this B portion denotes usually bytes, so that this information is bytes. So when we submitted this to the platform, it accepted the key, it accepted that as the key, so we thought that that was the correct key. What we actually needed was everything in here. So what their function's doing in the Python program is not correct. What it should do is take the input and then convert that to bytes instead of relying on the user to put that string in here. So it's literally taking this in and then it uses that as the conversion for the bytes when that's not what should happen. So if we cat that root root.py. So this here should say bytes plus the key, whatever we put in, not not asking us to put in that byte notation. And that was what was, I guess, really tripping me up, is that um, it was taking that and then trying to do some kind of function or a call or something with it, which was breaking the Python program, because again, it's not interpreting it as bytes, it's interpreting it as a complete string. So the author of the box should really fix this to convert input to bytes and then feed that into the key, and then that would make it work consistently. But we figured it out, and got the root flag finally. So just wanted to finish that up.